Well, good morning, good afternoon, good evening, whatever you happen to be watching this video. Hope it's a good time. First, I want to introduce myself. My name is Mark Webb. I'm going to be your instructor for this quarter. Been at Mid-State College since 2013, August 2013, so I've been there a little while. Um, we are going to be covering Advanced Java. This is CIS 255. Before we get started, make sure that you've already installed Eclipse. I have the instructions in Joule, so if you have not done that yet, go ahead and pause this video, go there, read the instructions, get it installed, and then basically come back. Because you can actually just follow along. All of the files are out there. I have links to all of the different files out there onto the S drive. I believe it, no, I'm sorry, the P drive out on the, I think you can get to it from the website or you can get to it from the classroom. Either way, all the files are out there. I'll have a link out there explaining where they're all at. So we are going to be covering the last part of the book I like to call the watermelon book, that we basically cover in three classes. CIS 113, we cover the first five and a half chapters, and then the next class, CIS 155, we cover the middle section, and then CIS 255, we cover the last part of the book, which is chapter 10 through chapter 16. So I'm expecting you to know how to program in Java. I'm expecting you to know how to do those things with Eclipse and whatever tools that you're used to. So if we can, let's just go ahead and get started. So chapter 11, we're going to start with chapter 11. And chapter 11 says we're going to be dealing with these things called exceptions. Now, what an exception is when you're running a Java program, there's actually two things that can go wrong. One is an actual error that's unrecoverable. You cannot get back from that, and it will basically just blow up. A lot of those are more due to software or hardware problems. Again, these are things that we cannot recover from. They're basically, they make the program blow up, and that's just nothing we can do. These other ones are called exceptions, and exceptions are, we'll call them errors in the program, but we can capture them. Now, what do I mean by that? Well, I'm going to go to Eclipse over here, and here I have a program that's ready to run. And I'm going to go ahead and run this program, and when I do, down here at the bottom it says we have an exception that basically says it's called the index out of bounds exception, and it's got the number 3 right there. What that says is, with the number 3, I'll get to that in just a sec. So if we look up here, we basically have an array. The array is the name of the array is called numbers. We've gone ahead and loaded it with 1, 2, and 3, and it's an int data type, so they're all integers. So it's an array of 3 elements. That's all it has: 1, 2, and 3. So I come down here and I've got a for loop where I go ahead and create a variable called I. It's an integer as well. I initialize it to 0, and then it says I'm going to go through this one at a time until this statement is false. Okay, so while I is less than or equal to 3, we're going to keep doing this loop. At the end of every loop, we're going to add 1 to I, the I++. That says add 1 to I. So I come down here, I do a print of numbers, which is my array, at this index. Okay, so if you remember from arrays, arrays always start with 0. So if I have 3, I'm going to go 0, 1, 2. So the highest number I can go in that array is 2. There is no 3. 0, 1, 2. So if we come through here, the first time through, I is a 0. We come back around. Is I less than or equal to 3? Yes. 0 is less than or equal to 3. I'm sorry, we've added 1 to it, so now I is a 1. So is 1 less than or equal to 3? It is, so it comes in here and it basically displays the next element in the array. So it goes to the number 1 position and displays that, which happens to be the number 2. Because we looked, there's 0, there's 1, there's 2. At the end of the array, we add 1 to I, so we come back around. We say 2. Is 2 less than or equal to 3? It is. So we go ahead and come into this loop, and we display this array at this element. So that's 2. So there's 0, there's 1, and there's 2. We add 1 to the I. We come back around. Is 3 less than or equal to 3? Yes, it is. That is true. So it comes down here and it says go to this array at this element, element number 3. Is there a third element? No, there is not. We have 0, we have 1, and we have 2. So that is what is known as an out of bounds exception. We've tried to go into that array at the third element that doesn't exist. So the way we would fix this is I would just change that less than or equal to 3 to just less than 3, and I save it, I run it, and look at that, it displays 1, 2, 3, and life is good. Okay, so out of bounds exception, you'll see that a lot when you're dealing with arrays, because we usually try to go outside of the array and it says, sorry, there's nothing there. You have to stay within the boundaries. You can't go out this side or this side. So let me bring up the book. So that's kind of what this first ideal was talking about. And it comes in here and says that basically we have a class called exceptions. So let me show you what that talks about. So if you remember from chapter 10, we talked about the object class. Every class out there extends from the object class, so it has everything that's inside of objects. We also have this other class called throwable, and it is extended from the object class. And then we have this one called an exception class, and that extends from the throwable class. So it has everything that throwable has and the object has. And over here we have an error. Now flat out error, again, I talked about that earlier. There's nothing we can do about it. That basically just flat out it's going to bomb, and there's nothing we can do. With an exception now, we have a whole bunch of different methods that allow us to capture each one of those different errors that come up. So for example, here's an I/O exception, an input-output exception, and there's other methods or parameters inside of that particular item that allows us to get more specific. We have an end of file exception, file not found exception, and there's a few others that go along with that as well. Here's a runtime exception. So there's a divide by zero. I don't think it's called divide by zero, but we can capture a divide by zero through this exception process. So the bottom line is this: as a programmer, whenever we create a program, we should never, ever, ever, ever allow a program to blow up. What do I mean by that? Well, before a program blows up, we should display some type of error to the user to tell them what is wrong, give them a chance to fix it, and then we will run the program, and then we will end it as the programmer. We never ever want to let the red text pop up and say, out of bounds exception or end of file exception or whatever exception happens to come up. We need to capture those and display, and then again grab that message and display something back to the user and say, hey, you've done this wrong, you need to do it this way. So for example, you need numeric values to do any type of mathematical equations. They type in a $sign or they type in a comma. Well, those things are not allowed in numeric values, and we can capture those and then display that message back to the user and say, hey, you can't use $sign or a comma, you have to use just numbers. Okay, so how do we handle an exception? Well, the way we would do it is we have a thing that's called the try-catch clause. And the try-catch says, hey, go ahead and try this. If you get an error, or I should say if we catch an error, we're going to do this. So we come down here on page 702. It says try file, new file. So again, file is a class. We're creating an object called lowercase f file, and we're instantiating it as a new file, and this is the file name. Okay, I've got my scanner keyboard input. So basically we're setting it up so that we can capture things from the console down below. Notice I say catch, and here I'm catching a specific exception called the file not found exception. I believe we saw this in chapter 2 or 3. Basically says this: we're trying to open a file that doesn't exist. So this is the class name, and this is the object we're going to create from it. Now that can be anything you want. You can give that any name you want. We've kind of gone to the general lowercase e as our exception objects. So if you ever see a lowercase e, it's basically an exception object. Again, you can give any name you want, but that's kind of what we've done in the Java world, is just gone ahead and went lowercase e. So we come down. Let's go down here and look at this thing called open file. So I come over here and I open the open file Java. Now if we take a look at it, so we've got a static void main. That means this is executable. Here I've created a file object called file. Now it's not instantiated, it's just an object sitting there. So again, until it's instantiated, think of it as a house with 4 walls. That's all it has. There's no guts on the inside, so the house is not livable at this point. So file says I've created a 4-wall house with no guts inside, so I can't use it yet. And then I create my scanner input file, and I got my string file name. So now I come down here and I say file name equals Java or JOption pane. So I'm saying I'm going to display a box and let you type in a file name. Then it comes down here and says try. And it says file equals new file. So here's my file object. I am instantiating it as a new file object with this file name, meaning go out, see if that file exists, and then bring that data into my shell, my house. And now once I open up that file and I bring it in, now my house has stuff in it and it's usable. But let's say it doesn't have it can't find the file. Well, right here it's going to catch file not found exception, and it's going to display file not found. So it says catch the error, the exception. If it's a file not found exception, we're going to go ahead and display that. Okay. Now up here I say JOption pane, show message dialog box, the file was found. So it says if it executes this line right here, if there was no file found, it automatically goes to this line. This line will never get executed. Once it gets through with this try catch statement, and again, it's going to do one or the other, not both. So I come down here and it says JOption pane, show message, show done. So it's going to display a box that says done, and that's going to get executed either way. And then we're going to go ahead and exit the system. So we're going to display the file was found or the file was not found. So I can't remember what the file name is. Let me check real quick. Looks like we'll call it letters.dat. Okay, so I'm going to go ahead and run this guy, and I'm going to type in letters.dat, hit the, and it says file was found. Come back and it says done. Okay, so the file was found. So it hit this try statement. It basically tried to open up the file. It went ahead and tried to instantiate the file. It did. So it goes ahead and displays file was found, and then it goes on down here to this done clause. It didn't do the catch because we didn't catch an error. I'm going to run it again. This time I'm going to type in name.dat. I click it and it says, whoa, file was not found. So again, and it says done again because it always does the done. So again, it tried to instantiate that file. The file didn't exist. So it didn't even do this input file or this JOption pane file was found. It automatically jumped down to the catch statement, caught the error, and then displayed it. Now, if there was another error that popped up instead of a file not found, it would not have been caught. This guy only catches a file found exception. That's all it will catch. So going back over here. So again, that's we kind of went through that whole step right there. And again, this goes into a little more detail, basically what happened, again, with the try statement and the catch statement. If life is good, it's going to do everything in the try, and it will not do anything in the catch. But if any time it gets an error inside of that try, it's going to jump down to the catch and see what exceptions are there that it can basically display. So right here we have what's called the default error message. It says each exception method or object has a method named getMessage that can be used to derive a default error message. So there is a message that we can grab. So let's go ahead and look at this exception message in Eclipse. So I open it up, and here's my exception message. It's a void, static void main, means this is executable. Again, I've created an object file, which is a file class, a scanner input, and a string file name. Okay, so that we've got a variable called file name. I go ahead and grab the file name is equal to the JOption pane into the name of the file. It's the same thing here. I go ahead and say try file. So really nothing changed at this point, except the only difference now is this statement right here. If we get an error, it says JOption pane show message dialog e.getMessage. Okay, so up here it said file not found exception E. So if we have a file not found exception, it basically then takes this class and creates an object E. What's an E? E has everything that class has all the instance variables, has all the methods, has everything. And one of those methods is called getMessage. So there's a getMessage method that's in there. So if I run this, and I'm going to type in name.dat and I click OK, it says name.dat, the system cannot find the file specified. So here's what happened. I loaded the name.dat file into that class, into the constructor. It went in, tried to open it. It didn't find it. So it went ahead and captured that exception and threw that into the file not found exception, which then created the object E. E then has everything, because again, I cannot use the file not found exception class directly. I have to basically create an object from it, if you remember that from chapter 6. So then what happens is that E object now has all of the methods, and that's where it comes up and displays the object that was trying, the file name object that was trying to open, in this case was name.dat, and the system cannot find that file specified. So that is the message that is built into that method. So pretty cool stuff. And then we go ahead and display the done. So again, the exception class, we can capture every type of error that can basically come up. Okay, so go back to the book, and so all exceptions have their own messages as well. We have a parse int error. So let's take a look at that guy, parse int error. So look at parse int error, and again, static void main, it's executable. I create a string str object or variable, and we've loaded it with ABCDE. I create a variable called number, which is an integer data type. I say try number equals integer.parseInt string. Now, what does str have in it? It has letters A, B, C, D, E. I'm trying to convert those to an int and then throw that in a number. You think I'm going to get very far with that? Probably not. So there I've got a number format exception. Now, that's just kind of the The good and bad about exceptions is you have to kind of go into the Java API. And if you don't remember what the Java API is, it is you do a search out in Google, it's basically the Java Programmer's Bible is really what it is. And it has all of the different classes, the methods, the instance variables. It has everything that basically comes with Java is out here. And so if we were to come out here and do a search for the exceptions, we could find a listing of all the different types of exceptions that are basically available to us. And so one of those happens to be the number format exception. So up to this point, we've seen the file not found exception. Here's another one, number format exception. Again, we got the class, we create the object E from that class, and now I have the messages for that E class. So I display conversion error and then the E.getMessage. So again, if I run this, it comes up and says conversion error for inputting string ABCDE. Okay. So for input string ABCDE was a built-in message. It went ahead and captured that particular data from that object, the str object, and displayed it in that message. Now again, if I did this, if I were to come in here and comment out all of this stuff, here I've got my number equals integer parse int. Okay, what is it blowing up on? Oh, I need that as well. Okay, so I've got that all basically converted over. I save it, and now when I run it, boom, this is where I get my number format exception. Again, we need to capture that and display the message to the user. Okay. So continuing on in the book, again, what if we have multiple catches to handle? Meaning file not found exception, number format exception. I could have possibly more than one error in a particular try statement. So what we can do is we can capture multiple. So let's take a look at sales report. So sales report, we go ahead and we've got a file name, so it's a string. It's a file name, it's called salesdata.txt. We've got int months, we create a variable called months, it's an integer data type, we initialize it to 0. We create a variable called 1 month, it's a double data type. We create a double total sales, we initialize that to 0.0. And we also create another variable called average sales, which is a double as well. So I say decimal form, so I'm going to basically have some formatting of my numbers, and it looks as though I want to have a comma and then 2 decimal places. So again, this decimal format will go ahead and put a comma in a thousand separator and then automatically round to 2 decimal places. So here I've got my try statement. Pretty good size try statement, because if you look down here, we have a catch file not found. But if you notice, I have another catch statement, which is the input mismatch exception. And then it breaks out of that, and we have a system.exit. So here I've got a catch file not found and a catch input media input mismatch exception. So if we get a file not found exception, it will automatically knows to hit this clause, this catch. If we have an input mismatch exception, it knows to automatically hit this catch statement. So again, now we can get more specific in our catches of any exceptions. So go ahead and run this. The file salesdata.txt does not exist. So it looks as though it caught it in this exception right here. It didn't even look at this guy over here. In fact, it actually hit this statement right here, got an exception, went directly to that catch, displayed that statement, and then went directly to system.exit 0. So it didn't even do any of this information, did none of it. So if I look over here, let's see what file do they want us to use? Wow, I don't even see a sales data. Okay, Okay, I've gone ahead and created, I paused this and then went ahead and created a sales data.txt file. So if I go ahead and run this guy again, it basically says sales data.txt does not exist. Ah, they lie. Sales data.txt. Let's see here. Okay, I got it fixed. So here's sales data.dat. I went ahead and changed the DAT. So now if I run this, it comes up and says the number of months was 6, total sales were that, average sales were that. So you went ahead and read all of those different items. So what did we do this? So if I go back in, I'm going to open up sales data, and I'm going to go in and I'm going to go ahead and change just one of the numbers to a letter. Let's see what happens. So I save it, and now when I run it again, it comes up and says non-numeric data found in the file. So if I come down here, look at this, input mismatch exception, non-numeric data found. So again, it found the file, it went ahead and did all of this processing, but then when it was reading each line of the file and it came to that numeric value that had the letter A in it, it basically hit this exception and it caught it, displayed the message, and now we basically have we can display that to the user. I mean, let me see what it shows again. It basically, yeah, it did. So it didn't show us the actual data itself. So is there a way for us to do that? Could we basically display that? So what if I did this? Well, apparently I can't pass that down there. So well, let me initialize the variable, see if that will help. Yeah, that helps. Okay, so now what I've done is this, is I've gone ahead and displayed the actual data of the item that's basically blowing up on. So up here I'm saying 1 month equals to, go ahead and read the file. So I'm going to read it, put it into 1 month, and then because I'm going through this loop, this while loop, one at a time, reading each record, and then I'm going to display that particular item. So now if I run this again, it comes up and says, it's not showing what I want. I wonder if it's because it's showing my next item. Yeah, it's showing the previous item. So let's talk about that. So here's basically what happened. This guy, when it comes around and does a read, it's reading the next record, and that's when it's blowing up. So it's blowing up before it even gets to this one. So we're actually displaying the next item. So let's see. Yeah, anyways, there's a way to go ahead and peek at the next record so we can actually see that, and that's probably what we'd want to do. We want to show the user what's making this thing blow up. We just don't want to display a message, a generic message saying, hey, we got a problem. Well, what's the problem? Don't have any idea. So it's probably a good idea to go ahead and display what's causing the problem. Okay, so um, so we can see how we can capture an exception. We can see how we can capture multiple exceptions. And we see what happens when we don't capture exceptions. The program blows up, displays this goofy red message to the user. User has no idea what to do. So let's take a look at sales report 2. And so here we basically have the same thing. We've got sales data. I'm going to change that to DAT. So here's my DAT. Again, we initialize the months. We have 1 month. We have total sales. We have average sales. We've got our decimal format. We've got our scanner input, and we got our same while loop. So here we are. Do we have the same while loop? I don't think so. Yeah, we had a try catch right there. So now what we're doing is we've got a while loop. It says while the input file is not equal null, or while input file equal null. If the file name is going to display error, file name does not exist, enter another file name, and then go ahead and let the user type something in. Okay. So if the input file has nothing in it, that means either you type something in or you've got an empty file. Then we're going to display that error message to the user and then give them another chance. So this is a great example of how we can let the user fix the problem and continue on the program. So then once we get through that, we're going to say while input file has next. And that's basically what I wanted to see at the next one. So has next says while there's another record, go ahead and keep running this. And then this is where we put our try catch statement in. So this is where we grab the 1 month total sales and then we add one to the month. So we're trying to basically get our total sales, and then we can actually then figure out what the total sales were, the sum, and then basically the average. Again, if we have a type mismatch, we basically do that. So here's what we're doing. We're actually capturing the file not found in this while loop. And then we only have one input mismatch exception that we're basically dealing with at this point. So we're not really even dealing with a file not found exception. We're just checking to see if the input file is not found. So I'm gonna rename this to sales data. I'm gonna call it TXT, just like it was up there. And save it, run it, and it comes up and says, hey, sales data does not exist. Try another name. So we're going to try sales data.dat. Click OK, and non-numeric data was found in the file. Okay, again, I have that letter A in there. So if I go back in here and change out letter A to a numeric value again and rerun, again it comes up. Now watch this. If I said sales data.txx, it's going to come up and say, hey, that doesn't exist either. Again, we got a while loop. Now this while loop could be an endless loop. You have to type in a valid file name. So sales data .dat, and now it comes up and says how many months there were, what the total sales were, and what the average sales were. So everything basically worked at that point. So a couple of different ways to handle things. I'm sorry, I didn't even catch that part. So right here, if we look, we got the file. So right here I've got input file equals open file. So here we're actually calling another method down below with the file name. I just noticed that. So what we're doing here is this is where we actually have another try catch statement. So we've got our try catch on file not found up there. So again, apparently we did have two exceptions. So there's two exceptions. One is we're catching inside of one method, and we've got another one caught inside of another one. You'll see they pretty much both programs do the same thing. One just basically breaks it up into two separate processes. The other one has a try catch with two catches. Okay. So handle each exception only once in a try statement. So try, catch, catch. So again, we basically can catch specific items. So kind of getting back to our inheritance. Again, everything inherits from object. Then we have a throwable class that inherits from object. We have exception, which inherits from throwable, which inherits from object. Runtime exception inherits from exception. Illegal argument exception inherits from the runtime exception, and number format exception inherits from the illegal. So again, we've got one guy inherits. So again, here is a parent child. Here's the child of that parent, child of that parent, child of that parent, child of that parent. So again, what is object? That is the grandma, great grandma, great 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 great. Okay, so here we have a try, a catch, illegal argument, number format. So again, we can really narrow down the specific exceptions that we need. Now, we do have one more part of a try catch, and it's called the finally clause. And let's see, we take a, I think I have an example over here. So here we have try, open a file. Then inside of that we have another try to read the file, and then we have a catch, input mismatch exception, and then we have finally. So finally says if you have a try and a catch, the catch is going to capture the error. The finally will do whatever you need to do. If there's anything you need to do, so if there's an error, you may need to close that file in this case. The finally will always execute after a catch. Okay, so if we have an input mismatch exception, it will go ahead and close the input file. If we try to open it, we catch the file not found exception, and then we have a try inside of a try, which if this is successful, then we're going to try to read it. Final, if we look up here, it says the try statement has an optional finally clause, which must appear after all of the catch statements. The finally block is one more statement that are always executed after the try block has executed and after any catch blocks have executed. So it will execute after a try and a catch. So realize we do have an option to basically execute the finally. Now here's the question. Since I have this try statement up here, if it catches this guy down here, will this finally execute? No, it will not, because this try statement never executed. Again, this try statement is only going to execute if we're successful in opening this file. Okay, starting in chapter, I believe it was 5, we got into calling methods. And one method can call another method, and that method can call another method, and that one can call another method. So what we call that is what we call a call stack, meaning this method called that method, which called that method. So it's a call stack. So they basically go in that order, and they have to come back in the same order. So if A calls B and B calls C, C's not going to go back directly to A. It has to go back to B, it has to go back to A. And so we have this thing called a stack trace. A stack trace is a list of all the methods and the call stack. It indicates the method that was executing when an exception occurred. So if we get an exception, we can actually see where it was in that call stack. So we look at a stack trace program. So again, we have a public static void main, it's executable. We print it out calling my method. We go ahead and call the my method, which is right here. And then we say system out main method is done. And then inside of this my method, it's basically calling the produce error, we call produce error, and it comes in here and says str. It creates a string called str, loads it with ABC, and then we go ahead and system out str char at 3. Now again, this is like an array. I'm trying to say display the character at position 3. We're going to get an error there. Why? Because we are at position 0, 1, and 2. There is no 3. So we're going to get an error. So we need to know where the stack trace, where did it happen in the stack call. So if I run this, it comes up and says we have a string index out of bounds exception. And it says stack trace Java 35, 22, and 11. So it basically is saying it blew up at 35. 22 is where this stack was called, and number 11, line 11 is where this was called. So if we look, here's line 35. Here's where it blew up. Exactly right. 22 is where that stack was called. So if we go up here to 22, right there, produce error, that's where that line was called at. And 11 is where the 22 line was called. So I come up here to line 11, yep, my method, that's where it basically called that method, and then it basically called the, so again, we can kind of trace back where things were called and kind of who caused this error. So if we look over here on page 719, it says handling multiple exceptions with one catch clause. So if we come in here, now let's just look at the program. So here's multi-catch. So I look at multi-catch, and here's my public static void main. I've got an int number, so I've got a variable, it has nothing in it, but it's an integer data type. I'm trying. I say file numbers.txt. And I create a scanner input, and then I say while the input file has next, I say number is equal to input file has next, and I go ahead and print that number out. And when I get done, I do a close. And then on here I have a catch file not found exception, and then I've got my pipe symbol, which is an OR statement or an input mismatch exception. So I can have one catch statement captured two different exceptions. Whatever exception it catches, it's going to go ahead and throw this into the EX object. And this is where I can then, I can say error processing the file. And I could go ahead and do an EX.message right there if I wanted to. So if I run this, this is error processing the file. So we basically captured the error. I'm going to see if I can capture whatever the problem was. So let's see if we can capture what the error was. So I'm going to go ahead and ex.getMessage. So run it, and error processing file numbers txt. The system cannot find the file specified. Pretty cool. So it basically said it couldn't find the file. So again, was it the input mismatch exception? Was it a file not found? So if I do a sales data txt here, I'm sorry, DAT, and I run this guy again, it says error processing the file was .null, so there was no anything in there. So, which I believe there should be, right? Yeah. Sales data txt. So sales data dot dat. I wonder why I couldn't find that file. Let's see, so numbers.dat. So let's try that one. File null. That's strange. Let's see what they say in the book here. So, but anyways, the whole point of the exercise is realizing we can catch multiple exceptions by using the pipe symbol. So what happens if an exception is not caught? says when an exception is thrown, it cannot be ignored. It must be handled by the program or by the default exception handler. So, in Java, there are two categories of exceptions, unchecked and checked. And unchecked exceptions are those that inherit from the error class